Hello everyone, welcome to this class on predictive analytics / machine learning. In my opinion, the two terms mean almost the same thing, so I'll be using the two terms interchangeably. Let's get started right away with the first unit, which is of course an introduction to the course. Let's move on to the first lesson of this unit, lesson 1.1. I'm just calling it as analytics landscape, just to introduce some terminology here really. So basically in data analytics or business analytics, or call it what have you, you've got a data set. And of course, for this discussion, the details of this data set are not necessarily important. So I'm just showing you that you've got a data set with lots of rows, lots of columns. And in analytics, there are two things you might want to do with it. The first thing that you would generally do with any large data set when you start working on it is to try to become familiar with the data set. So what you'll do is exploratory data analysis. So in this, what you're really trying to do is to say, okay, I've got this new unfamiliar data set. Let me become familiar with it. Let me explore it, see what kind of patterns exist in it, etc. Predominantly, exploration occurs in the form of visualizations, but not entirely only visualizations. You could also generate summary reports, look at correlations, look at some summary report, all kinds of summary statistics and so on, just to wrap your head around a complex data set. Okay, you just want to find out, okay, for these columns, what's the average? Or in this column, how are the data distributed as opposed to that column? Is there any correlation between these different columns, etc., etc.? Okay, so that's really what you're doing with data exploration. Like I said, predominantly it'll involve some sort of visualization or other. You might also be looking at, well, are the data widely dispersed or are there well-defined clusters within the data? That kind of thing as well. On the other hand, in addition to exploration, in fact, you'll always start with exploration, you might also want to use this data to be able to do some predictive analytics, right? So you may want to say, well, I want to predict the price of something, right? I've got historical data on prices and a lot of factors that affect the prices. Now that I've got this historical data, why don't I try and say in a novel situation, what is the price likely to be? What is the GDP of a country likely to be? Or given a person, will this person buy my product or not? Or, will a person to whom the bank is considering giving a loan, how likely is that person to default on the loan? That kind of stuff. So these are predictions. That is trying to find a value for something whose value you do not know and for which you do not have the data. So you're trying to leverage your historical data that you have in order to find a value for something whose value you do not know. Okay, so those are two broad kind of tasks that you will perform in analytics. But of course, the word predict, right? This course is all about building predictive analytics models, but the word predict can be slightly misleading in the context of analytics, right? I mean, normally when you use the word predict, you're obviously trying to talk about the future. You're trying to predict the future because the word pre itself means before, right? So predict is always talking about the future. But in the context of predictive analytics, you may not always be talking about the future. So in that sense, it's sometimes a misnomer. Okay, so in this sense, it may not necessarily be about the future. A more correct way of saying it would be, we are trying to use whatever data we have to find the value of an unknown. Okay, it may not be in the future. It may have already occurred, but you don't know the value of that variable. So you're trying to use your past data to try and figure this out. Okay, so let's take an example. So for example, let's say that a credit card transaction has taken place. Okay, now your credit card company, based on historical information about various transactions, might figure out that there is a good likelihood that this transaction was a fraudulent transaction. Okay, now it doesn't know that it's a fraudulent transaction. Maybe it's you who's actually performing the transaction, but based on information that the model has, it's saying it's unlikely that this transaction was made by you. Maybe it's a fraudulent transaction. Okay, So the model is just figuring out maybe it's a fraudulent transaction. Okay, so you would call this as a predictive model, right? But the transaction has already occurred. Either it's fraudulent or it's not fraudulent. It's in the past. Okay, so the predictive model, as we would call it, is actually not predicting the future. It is simply determining the value for that transaction, whether it's fraudulent or not fraudulent. Okay, so in this sense, all it's doing is giving us the value of something whose value we do not know. But it has occurred in the past. It's not about the future. But we still call these as predictive models, even though it's not really about the future. Okay, so just be aware of that. When we say predictive model, we are not necessarily talking about the future. Just to be clear, I don't mean to say that predictive models are never about the future. In fact, often they are about the future. All I was trying to clarify here is that it need not always be about the future, right? So in that sense, the word predict is actually a misnomer in this usage. Nevertheless, this is the sense in which we are going to be using it. Another situation in which a predictive model is not really about the future is a very popular example. This is an example that Google did some time back. They built a model to predict the occurrence of flu, right? So the Centers for Disease Control, it's important for them to know which areas of the country are affected by the flu so that they can, send in vaccines and take preventive action or take corrective action. But it's important for them to know which parts of the country are affected by the flu. Now, earlier, what they used to do was, of course, gather data from physicians and so on, let the data percolate through the system and then reach the analysts who would then analyze and say, okay, this area seems to be having a lot of occurrences of the flu. Right now, Google, what they thought was that since everybody is using search for anything and everything, they thought, okay, when a place is affected by the flu, the people living there would be searching for certain common terms, right? Because these days, whatever happens, when we want to learn something about anything, we go and search on Google. So Google thought that looking at the search terms might be useful. Okay, so what they did was of course, you have Centers for Disease Control has historical data on which parts of the country were affected by the flu on what date. Okay, that data is already available. Now, interestingly, what Google had been doing, of course, right since the beginning of search, is they were always storing information about the various search terms that people were using. Not only that, they also store information about, from which location the search actually occurred, right? So they have a way of looking at, from a particular location, what are the terms that people were searching for. So obviously, if a place is affected by the flu, then the people who live in that area would be searching for things like cough and cold and infection and flu and several other related such terms, fever, stuff like that. Okay, so they just did a simple analysis of what are the terms that are good predictors of the flu, and they in fact were able to find some, I think, 80 or 100 odd terms, which if a lot of people are searching using those terms, then it's very likely that the place from which they're doing the search is affected by the flu. Okay, so once again, you could say this is a predictive model because it's determining whether a particular place is affected by the flu or not. But again, this is not about the past, right? The place is already affected by the flu, and then people who are living there are using search terms to search for something, right? But the point of the matter is, even though the event has already occurred, the place has been affected by the flu, well, we don't know which places have been affected by the flu, right? So this model is helping us to figure out whether a particular place is affected by the flu or not. Okay, so it's not prediction in the sense of predicting the future. The event has occurred in the past, but it's something whose value we do not know, and the model is helping us to find that out. So once again, just reiterating that the term predict may not necessarily apply to the future in this particular context. So let's take some examples of applying the term predictive modeling to future occurrences as well as to past occurrences. Okay, so here are some examples of where the term predictive model is actually applied to really predicting something that's happening in the future. So for example, predict whether a particular person will accept a loan or not if offered. In other words, you've got a bank and the bank is thinking of making loan offers to several people. Now what they want to know, of course, is they want to make these offers to people who have a high likelihood of accepting the offers, right? They have not even made the offers yet. So they're just saying, if I made an offer to this person, what is the likelihood that the person will accept? Okay, so that's a genuine prediction about the future. Okay, so the point is you make a loan offer based on the model prediction, right? That is, you say, okay, if I offer a loan to this person, what is the likelihood the person will accept? If the model says the likelihood is high, then you say, okay, I'm going to make a loan offer. So therefore, the acceptance or not is going to happen in the future. Okay, here's an example of applying to a past occurrence, and this is the same credit card example that I mentioned earlier, right? So you examine a credit card transaction and then determine what is the likelihood that this is a fraudulent transaction, but the transaction has already occurred. It is in the past, and it is either fraudulent or not fraudulent. So all we are trying to do is to simply determine that. Okay, so clearly this is not a case where anything about the future is being determined. Okay, so these are two examples. So the word predictive model is used to explain or refer to both of these kinds of scenarios. Let's look at some core ideas in analytics. Okay, so first of all, of course, we already spoke about data exploration, okay, which is meant to understand a data set. So you've got a data set, and it might be an area from an area which is completely new to you. So you don't understand too much about the field. So you need to explore the data, wrap your head around the data set, and data sets can often be very large, right? So there is a lot of effort involved in trying to understand a data set. That is data exploration. And in fact, in an earlier course, you've gone into great depth about data exploration, right? So we learned about things like the dplyr library that allows us to really manipulate the data very easily in many different ways. We learned about ggplot, where we could visualize the data in many different ways quite easily. So that is all about data exploration, which is partly about visualization, right? Data exploration is a general area. Visualization is a very important component of data exploration. Okay, then you have this whole aspect of data reduction, right? So now quite often what happens is you get a data set which is quite large in terms of number of rows, and large even in terms of number of columns, right? So in order to simplify the process of working with the data, in order to understand the data better, we engage in a process called data reduction, which is to say, okay, I've got a data set which has 150 columns. Is there some way by which I can reduce this to a different data set which has only 10 columns, but without too much loss of information that was existing originally in the 150 columns? Okay, so that is an area called data reduction, which we will not be going into in this course, but that's an important aspect of analytics. Another, commonly used method in data analytics is affinity analysis, which is also called market basket analysis, which is basically the kind of method that companies like Amazon use, right? If you buy something, then they're able to say, okay, if you bought this, then you might also be interested in this other thing or these other things. Okay, that is called affinity analysis. We might go into that in this course, but it's not truly a predictive analytics, because it's not predicting that you will buy something. It's just saying that, people who bought this also tended to buy that, so they're making a recommendation. Okay, so it's not what is called as a supervised learning technique, and we'll get into all of that later. And then the two important things that we'll be looking at in this course are classification, which is you've got some data and your prediction is simply in terms of, does something belong to one class or the other class? So for example, to take a concrete example, let's say you've got a whole set of people on whom you have the data. All you want to do is, for every person, you want to classify them as a person who is likely to buy our product or not, right? So we are just saying this person is either going to be a buyer or a non-buyer. We are putting the person into one of two classes. Buyer is one class, non-buyer is another class. Okay, that's a classification example. It doesn't necessarily mean that there have to be only two classes. So for example, you may classify people based on, let's say, what you expect their salary to be. And you're not predicting a number for the salary. You're only saying this person's salary is likely to be high, medium, or low. Okay, so that's again just three classes. Okay, on the other hand, so those are classes. So for example, in an earlier example, we looked at credit card transactions. And that is again a classification problem, which simply says, is this transaction a fraudulent transaction or not? Again, just two classes in that particular example. Okay, so those are all classification problems. So for example, if you use Gmail, right, either your mail comes into your inbox or the mail goes into spam. Okay, so again, Google, what it has to do when it looks at every single message is to classify the message as a regular message or a spam message, right? Or alternately, these days, if you look in Gmail, it also classifies a message as primary or promotional or social, right? So for example, any Facebook related message may go into your social tab, or any promotion of some product will go into promotional tabs. Other messages go into your primary tab. Once again, how does Google put it into these three tabs? Well, it has to look at the incoming message and classify the message as belonging to one of those three categories and accordingly show it into your appropriate tab. Okay, so all of these are classification problems where you're taking a particular occurrence and saying this occurrence belongs to one of these few classes. It may be two classes, it may be five classes, doesn't matter, but a small number of classes. You're not making a prediction of a particular number. Okay, and that is called regression, right? That is when you are in a scenario where you don't just have to predict that something will fall into one class or another or a third class. You really have to give a number. So for example, what is going to be the number of units our company will sell in the next month, right? You're predicting a number. Okay, you're not just saying, it belongs to this class. No, you're predicting a number. The sales may be 10,000, it may be 15,000, it may be 12,340. Whatever it is, you're predicting an actual number. Okay, that is what is called as regression. When you're predicting a particular numerical outcome, it's called regression. When your output is just a class, it's called classification. Okay, now you should not confuse the term regression with the term linear regression, which you've no doubt heard of already. Linear regression is but one technique for regression. There are many other techniques as well for regression. Okay, so when we use the term regression by itself, we are not talking specifically about linear regression. When we refer to linear regression, we will use the complete phrase linear regression, not just regression. Okay, so when you're predicting a number, it's regression. When you're predicting a class or a category, it is classification. Okay, so broadly speaking, these are the kind of activities we perform in data analytics in general, but specifically in this particular course, we are mostly interested in classification and regression models. These are the two kinds of models which make predictions based on which we can perform business decisions. That's the whole idea.